Greetings, statistics class. This particular video is made for Chapter 6.3, Section 3, so Chapter 6, Section 3, and this is problem 3 from the homework. These types of problems are often referred to as reliability problems, or sometimes called warranty problems. So let's take a look at how to solve this problem, and I'm going to use technology instead of the charts in the back of the book. So you have this watch manufacturer, and they have shown that the average life of their watch is about 36 months. So it says 36 months. After that time, the watch can become unreliable. So the standard deviation of watch lifetime is 7 months. So this 36 months is on average with a single standard deviation of 7 months. And they have found that the distribution of lifetimes is approximately normal, right? So it's normal. So they want to give a guarantee, full refund of defective watches for 2 years. So remember, 2 years is 24 months. So everything's in months, right? So months, months. So 2 years, we have to switch to 24 months when we think about it. What percentage of total productions will the company expect to replace? So how do we solve this problem? Well, we have to think about when the watch is brand new, like the day it rolls off the manufacturing process, it is 0 months. And we are asking about how much area is under the curve from 0 months when it runs off the production the first day to 24 months or 2 years. So what's the area under the curve, a normal distribution curve, from 0 to 24 with a mean of 36 and a standard deviation of 7. So let's take a look at that on our calculator. So I go to second and then the distribution menu. So I'm hitting second vars to get to distribution. And I want the normal CDF. And then it goes lower. So lower is 0, right? The day it comes off the production line. 0 months, and then we're talking about 24 months is the upper of their the guarantee, and then it says the mean was 36 and the standard deviation was 7, I believe. Let me take a look at the problem again because I already forgot. So the average life is 36 months and the standard deviation is 7. So then I'm going to paste that. So remember, it goes lower, upper, mean, and then standard deviation, and I hit enter. So this is 0.0432, and then I have to be careful about how it's asking. See how it puts the percent here? So it has put the percent symbol, so it wants it in percents. So I have to multiply that number by 100, and that'll tell me percent. So 4.32%. So I put this in 4.32%. To 2 decimal places. 4.32 to 2 decimal places. And once again, I just multiplied this by 100 because they have their answer as a percentage. So if this watch company does not want to make refunds on more than 16% of the watches they make, how long should they guarantee your period be? So the way I do that is I go back up here to my normal CDF. So the 0 is the day the watch was made. This number, the high number, we don't know, right? But we want the outcome to be 16%, so 0.16. So we have the 0, the low number. We don't know the high number. We'll have to change that because we don't know what it is. And then this is the average mean, and then the standard deviation of 7. So I'm going to start at 50. Why 50? Well, it sounds good, right? So I think 50 months is like 4 doubled is 48, so that's like 4 years for a watch. It sounds good to start with. So I hit it and see how it's 97%, so that's way too high. So then I'm going to lower it down by 10. So let's see what happens at 40 months. And I try that, and it's 72%, so 0.716, so 72%, still too high, because we're looking for 16%. So then I go and I'm going to change it to 30. Just doing trial and error here. So this is close, right? This is 19%. So I'm going to try 29. See what I get. And so that's pretty close to 16%. So I'm going to say 29 months. So I just used trial and error until I found the 16%. So I'm going to do 29 months. So I do 29. And I'm going to sit with my answer. And I got both of them correct. So this is how I solve this problem using technology. If you have any questions, I'd be happy to help. Please let me know.